All right, today we're going to be going over T3 stack and integrating Sign-In With Ethereum with it. Now, if you're unfamiliar with the T3 stack, this is something I definitely recommend that you check out. If you're coming from a traditional Web 2 background and trying to build an app from scratch, this is a good base to start with. It is very TypeScript focused. It has TypeScript, tRPC, Prisma, Tailwind. It's built on NextJS, and you can have NextAuth built into it from the start. And what's nice about this is that everything about this stack comes with type safety. Basically, everything is typed out. So whenever you create something in your database, we know naturally that Prisma comes with types when you're defining the database schema. That will also translate with your tRPC requests as the backend all the way to your front end. So everything will be auto-completed and you'll know exactly what you're referencing, which is really, really nice and definitely expedites the development process. Now, if you're unfamiliar with Sign-In With Ethereum, I definitely recommend checking out Login XYZ. What it is basically a library that allows you to leverage your wallet to be able to sign transactions to confirm your identity or confirm specific things and give you permissions on a site. Now, signing messages with your wallet isn't new, but it just establishes a standard in order for you to understand, oh, hey, where is this request coming from? What sort of permissions should exist? And what am I giving permission to? And this is all based off ERC 4361, which is the Sign-In With Ethereum convention. Now, what is interesting about this too is that we can do this off-chain, so basically with websites, but we can also do it on-chain in terms of verifying signatures. Now, we won't be going into that today, but just a note that's something that you can use your wallet for off-chain and on-chain interactions for verification. But today specifically, we're going to be taking and leveraging Sign-In With Ethereum, working with the T3 stack. If you want to see the full repository, I definitely recommend this is the full walkthrough that we're going through. It's actually based off of an article I also wrote called Combine Sign-In With Ethereum with Create T3 App. This will go over the entire process. This is exactly what we're going to be covering today, as well as some small nuances of things that I've discovered for small fixes too. So I definitely recommend checking out the article, but if not, let's walk through this. So I have VS Code open. You'll notice that I have my Explorer on the right-hand side this time. I'm just trying to give this a try because apparently I've seen a lot of people say, hey, this makes a lot of sense. So the first thing I'm going to do is I'm going to be using PMPM. So I'm going to PMPM create T3 app latest. And what this is do is kind of scaffold things out for me to be able to make the decisions. And you might have seen like a Twitter post that I saw from Theo where you can actually say, hey, I want to be able to choose JavaScript as an option. And you'll notice that you can't choose JavaScript. You have to use TypeScript because the whole project is based on TypeScript. Now, the nice thing is it gives you the option of different, functionality that you might want to add to this to be able to kind of get you up and running. I'm going to choose all of them because I'm going to leverage every single aspect of the T3 stack to show you how you can do an authentication with Sign-In With Ethereum and be able to also leverage those sessions for, protected pages, etc. So now that I have everything scaffolded out, the first thing I'm going to do is run migrations. So you'll notice that in the Prisma file, we'll see a schema that's set up. These are some basic things that are already set up for us to, start a database essentially. So to do this, I'm going to go npx Prisma migrate dev. And you'll notice here it's going to ask for the first name of the migration. So this is just our initial migration. And you'll also notice that the file is set to SQLite. So this will create a database file locally so I don't have to set up like a Postgres. And this is a simple version of just trying to get a database up and working. So I'm just going to use init as my new migration name. And there we go. We'll see that the migration is finished. And if I want to see my database, I can just go npx Prisma Studio, and we should see it on localhost 5055. And you'll see that I have my entire database set up. You can select different tables, see what the schema is like, what the data looks like, and that's what we're going to be working with today. So I'm going to create another terminal because I want to keep that up and running so that I can reference at a later time. The next I want to do is I want to see what we're working with. So I'm going to go pmpm dev, and this should load up on localhost 3000. And we should see that this is the app that we're looking at. And if I click the sign-in process, it'll bring me to a page where I'm defaulted to be able to sign in with Discord. And this is already set up, if you look at our environment variables, to be set up or configured with Discord. So if we wanted to, we could allow other OAuth type sessions or authentication methods to be able to be configured. The next thing I'm going to do is add the libraries that I need for this specific project. So I need to add WAGMI, Sign-In With Ethereum, and Ethers at version 5.0. So what's important here is that at version 5, it's what's supported technically with Sign-In With Ethereum and WAGMI, and we need that. There's a lot of changes that came with Ethers 6.0. Now that that's done, I need to configure WAGMI so that it has the configurations for different types of networks or chains and allows me to auto connect with my wallet. So to do that, I need to go to my source, I need to go under pages, and then go to my _ app.tx file. Now I'm going to replace everything that's in here, and I'm going to go line by line what's going on. So everything else is the same from the top. Here we do the Sign-In With Ethereum integration. So we have our WAGMI config, create client, configure chains. We pull in the different chains that we're supporting, and the public provider, essentially the provider, which is basically injected from our Metamask from the Chrome extension. So here I'm setting up the provider and I'm passing in the client, and these are the chains that are supported, and the client will auto connect. So every time the site is loaded, it will try to auto connect for that wallet, the Chrome extension, which is Metamask. And then you'll see I wrap things, wrap the existing components with the WAGMI config, which is an ultimate provider or context over the entire application. After that, I want to modify our main page. Again, I don't want to try to modify it too much so that you're able to kind of see what it looked like before and what kind of functionality I'm adding to give it a reference. So if we went back, loaded the page, this is what we're looking at, and we're going to configure this now to be able to add the connection for our Metamask connection. So here I'm going to go to my index.tsx file, and then what I'm going to do is paste a whole bunch of code and go line by line what exactly that I'm doing. So a lot of it hasn't been changed. It's just formatting it slightly different. I like things a bit cleaner in terms of structuring things out. And you'll notice that there was an auth component that was there before. There's things that I essentially just commented out, but you'll see that I'll add them back later. And we're taking advantage of everything that would be from the WAGMI tutorial or the WAGMI site in terms of setting up to connect a wallet, and then from there show if you're connected, and basically allowing you to disconnect as well. So let's save this and let's load up the site. So you'll notice that there's a connect wallet button instead of the sign in, and this is just going to prompt my wallet, and you'll see that my wallet's already connected to the site and display the wallet address. So I'll connect, shows my address, disconnect, and vice versa. Now, there's an issue with NextJS because it is also a server-side framework, as well as there's a client-side component to it. If I refresh this page, you'll notice that there is a hydration issue. The hydration issue is where the backend that's rendered in terms of the DOM doesn't match what was presented on the client side. And you'll notice that what happens here is that the wallet address shows up at the very last minute because it's a client-side interaction. So we need to be able to just account for this so that it doesn't, like, there's not a mismatch between the backend and the front end. To make that change, I'm just going to modify my auth showcase component, and I'm just going to replace everything that's here. And the only difference that we added is basically a use state to be able to show the connection, and a hook to say, hey, once the page is finished loading, then show those components to be able to allow for the address to show and not have a conflict for hydration for the backend and the front end. Now, if we load the page again, you'll notice that there's no issues. If I disconnect and refresh and then connect and refresh, there's no hydration issues. In my article, I mentioned that you should install NextAuth 4.20, but there has been a fix to this in the latest version of NextAuth. So we'll look at the workaround for this to be able to get the nonce, and we'll get to this in a little bit. After that's set up, I want to configure our authentication sessions, piggybacking basically off NextAuth, so that we can establish our sessions and show that somebody's logged in and show certain data that wouldn't have been shown if somebody isn't logged in. So I'm going to modify a server auth file, and there's a lot that's going to change here, but I'll try to go line by line as to what specifically is changing. So let's look at our auth before I make any changes. You'll see that I'm getting my server-side props. There's a get server-side session, NextAuth options, default session. The provider is for Discord, and I have a Prisma adapter to be able to establish and store sessions within a database. And of course, I'm loading my environment file, and I'm referencing Prisma to be able to make some database changes. So you'll see here, this type, we're not necessarily changing any of this. This is probably where the bulk of all our changes are going to happen. This is the main configuration or options for our server sessions. And then you'll see here our get server sessions, which will take in the request and the response and return the get server session, passing in the NextAuth options. Now we're going to modify this as well, but as far as it goes, this is the bulk of what's going to change. So I'm just going to paste over this. A lot of these things, like it will remove the Discord provider. We're not going to be using Prisma because it's a credentials provider that we're going to be taking advantage. And with the credentials provider, it doesn't have a native database storage of sessions. This is just going to be done within the server itself, just managing those. And we're just going to take advantage of that as opposed to storing it into a database. So I'm just going to paste the code in here and we'll see everything that we need. You'll notice that the types haven't changed. The auth options is where the majority of changes have been made. You'll notice that now it's a function which accepts a context or a request and then returns the next auth option. And we can see that here, that the biggest change at the bottom here, where now our get server session is returning the options as a function and passes the context to it to be able to read certain data that we need from the headers. Now, one of the things that we're trying to read from the request is the headers for the cookies. And what has been passed is a CSRF, or basically a cross-server forgery token, to be able to prevent requests coming from any arbitrary server. So what this does is that every time a request is made, before an actual request for a mutation type of request, like post or put, it's going to call a GET request from the server, get a token, and then pass that token with every request, making sure that the actual request came from the server itself and not from another source or another client from that matter. So you'll see here that the callback I'm returning is a session. I'm getting the session, the token, and what I'm doing is just sending back the session with a updated user for the ID, which is token sub. And what this really is the actual wallet address that's being returned that we're going to leverage. You'll notice that there's other callbacks that we don't need to take advantage of. These are callbacks that are done at specific moments of leveraging NextAuth. There's sign-in, there's redirect, there's JWT. So at the time when a JSON Web Token is generated, which we'll be leveraging here too. This is redirect we don't need because we're taking advantage of being able to use this on the client side. So there's no redirects to that auth page that we saw before for Discord. And then you'll see other options that aren't needed as well. You can set a secret for the NextAuth secret to pass it on. We can pass in an adapter, which is the Prisma adapter. And what that really is a means to write data to the database for the sessions. Now, considering that we're not writing anything or storing any sessions within the database, we don't need to take advantage of this. And then the other options, if you wanted to come up with your own encoding or decoding of JSON Web Tokens, you can also leverage that too. And then the session configurations for the strategy, which is defaults to JWT and defaults to these specific values of max age and updated at. And there's some other aspects of generating a session token. And then there's events, which are like post type hooks you can kind of think of for sign in, sign out, create user, update user. And again, a lot of these are made for database interactions. You don't necessarily need this for the credentials provider. Now you'll see here under the providers, there is an array. So this accepts multiple types of providers. You might have Discord, GitHub. The unfortunate part is when you're doing that, it leads to the page, which we'll see, which gives you multiple options. The thing is with our Metamask wallet or just Web3 wallets that are Chrome extensions, they work differently than OAuth providers where there's a redirect and a callback. Everything is done on the client side. So I got to make sure that when I'm passing in a provider, I'm only passing in one, because otherwise it's going to think that I'm giving the user the option to be able to sign in with Google or GitHub for that matter. You'll also notice that I make sure that I don't add an ID to this, because I could have multiple credential providers, and giving an ID signals to NextAuth that there's going to be multiple providers, and it'll lead you to the sign-in page, which will show a sign in with Ethereum button, but it's not set up to be able to work with a Chrome extension like Metamask. You'll notice here's some defaults where I'm just going to set up the name of the credential is called Ethereum. The type that we're taking advantage of is credentials. There's other options, but this only works for this provider as credentials. And then these are fields that we're essentially giving it to so that we can read afterwards. When we're trying to set up a provider, normally these are fields that would be set up if we did like an email credentials. So these are form fields. So message and signature would be form fields, and we're just giving it a label and some placeholder data. We're putting this in place because these are the pieces of data that we also need to be able to catch when we're trying to do the authentication process. So next is the actual authorize functionality for this. You notice that I'm passing in the credentials, and there's a message that we expected to get from our wallet that's being passed. Now you'll notice that I'm using the credentials.message that's being passed through. And what I'm leveraging is the Sign-In With Ethereum library to be able to interpret that JSON and get the proper values from it. And you'll see here, we'll get our current cross-server forgery token, which was passed in our requests every time we make a request. So the current request that's coming through. And we're also getting the fields. So we're just validating the signature to get the nonce, all the other data that we got from that Sign-In With Ethereum message. And we're comparing the nonce that we got from the cookies to the nonce that's from the fields itself. Now, if they don't match, then I'm going to return null because it shows that the request didn't come from the actual server itself. And if everything does match, I'm going to return the address, which is coming from our Sign-In With Ethereum from the fields itself, which is the wallet address. Now, if there's any errors here, I'll console out that error and return null because I shouldn't allow for any authentication if the field nonces or anything goes wrong in terms of the validating the signature. The next thing I need to do is modify my NextAuth routes. And you'll see that here. So these are all the routes that would be based for callback or sign in for that matter for NextAuth. And we're trying to change that up to make sure that it just works with Sign-In With Ethereum. Now, a lot of this won't change that much. The only main difference that will change is now we're passing in a function for auth options, and we're passing in the requests so that we can pass in the cookies and take advantage of reading the headers for that specifically. So if we look at our server and we went to one of the default routes from NextAuth, so notice here I have the Sign-In With Ethereum fields for the message and signature. Now, a credential provider is usually set up for email authentication, and this is no use to us because we're not doing any email authentication and we're not using or leveraging Auth0 for that callback. So we're not going to take advantage of any of this. So to fix this, and we want to make sure that whenever a user, if by chance they go to this page, is not seeing this authentication because it's really no use to them. So to fix this, the only thing I need to do is make a modification to my auth function, which says, hey, if you're getting GET requests for the sign-in page, I want you to remove one of the providers, which is just popping off from that array, the credential provider. Now, if we save that and refresh this page, we should see that it no longer shows. So there's no opportunity for somebody to try to do an authentication with that specific provider. Once that's done, I'm going to head over to my main index page. And you'll notice that I'm going to be adding a few of these back. And I'm going to be adding some of this session data to be able to pull in. And I'm going to add some functionality where if they click, they'll be able to click the sign in button and establish a session. So I'm going to paste my new code in here. You'll notice that I'm taking advantage of the get CRF, the sign in, sign out, and use session functionality. We're adding some additional use network. We've put back the use session, the session data, and we're able to kind of get, if there's no user that's established from the session, don't try to make a tRPC request for that secret message. And in the meantime, everything else should stay the same. The only difference now is we added this functionality for on-click. So now we'll do a Sign-In With Ethereum. It'll prompt our wallet to sign that transaction or sign that message, create a signature, and then pass in that signature to the sign-in for NextAuth. So if we load this up, so you'll notice if I disconnect, that sign-in button disappears. If I connect, it'll show that sign-in button. Once I click sign in, it'll prompt my wallet for the message to sign. And if I cancel, it'll show the alert for the rejection. If I click it again and click sign in, you'll notice that nothing works. And this is the issue we talked about with the latest NextAuth version. So if you look at our console log, we'll see that we have specific errors where we're not able to read the data from our headers for the credentials. We're trying to get the cross-server forgery token. And you'll notice here in the auth section, when we're trying to retrieve that from our nonce under authorize, we're trying to get our cross-server forgery token passing in the requests. Now to fix this, because the headers are essentially dropped, I just need to be able to pass in headers and then go pass in the request.headers, which will essentially make sure that those cookies, etc., that are read are passed in through. So if I went to console log here, just to show you what that looks like. If I clear this out, let's try this again. I'll sign in. And you'll see that I've successfully established a session as a user showing my wallet address. Now you'll see that the secret message is unauthorized, and we'll get to that in a second. But as far as the headers go, all that data is being presented and being passed through to be able to establish that session. Now to fix this unauthorized secret message, which isn't showing up, we actually just need to modify our .env file. And the main culprit is really just our next secret that needs to be set up. So if we paste in a really long secret password of 32 characters, load up our page again, we'll click sign in, and you'll see that the secret message is being passed through. And if I refresh the page, my session is still persistent. So I can sign out, refresh, sign in, refresh, and you'll see that the session has been established and is persisted in this app. So if you got this far, you've established sessions using just your wallet, which is great. You're able to then prove if somebody's logged in or sign somebody out in that sense, and be able to verify those messages, those signatures on the back end to make sure that a session is established. Now, if you're here this far, you're great. Like as far as it goes, you've done the whole session with Sign-In With Ethereum and your wallet. This next step is, how do we leverage this to be able to do database transactions and store that data so that we can take it a step further, so we can create an account, ultimately do some to-dos or save a to-do list, and sign out, and it'll persist for that specific user. So what I need to do is modify my Prisma schema, and there's a few things that I no longer need. So the example is no longer needed anymore because there was no data for that. The account table I'm going to keep, and one of the reasons why you want to keep an account as well as a users table is that a user might have multiple types of accounts, but there's a unique user behind it. So if I had a unique user, let's say 1, 2, 3, 4, 5, but they had an email account as well as a GitHub account, then it's good to kind of have those a second layer to be able to abstract that and make sure that they're a little bit different. So I'm going to keep the account table. The session table I don't need anymore because as far as it goes, I'm not using the database to establish any sessions. This is all done through the server itself. I'm going to modify my users table to, instead of an email, I'm going to add the idea of a wallet address. And again, remove any associations to accounts and sessions. Verification token was there for emails. So if you wanted to create an account, it would probably create a verification token to verify your email. And then from your email, then ultimately create the account and successfully establish it in the database. This we no longer need as well. So just modifying this entire database, you'll see that there's a new to-do, which we're going to create to-dos that are associated to a specific user. You'll see that we have the date if it's completed or not, whether the user has said, hey, this is incomplete or not. It's associated to a user. The data was created, updated. There's the account. Nothing has really changed for the account table. The user table is where things have changed. We've kept the email. We just made it optional, but we also added address here that it'll be unique to the user. And we have associations to the accounts and we have associations to the to-dos. So to see these new changes take effect, I'm going to run npx prisma migrate dev. It's going to prompt me for what this new migration might look like. Do I want to apply these migrations? Yes. I'm going to give the migration a name called create Sign-In With Ethereum structure. Now we went back to the Prisma Studio. Let's stop the service and let's start it again. We went to localhost 5555. We'll see that we have our new database and there's a new structure for user account to do users. So the example folder, example table, and the verification table have been deleted. And we'll see under our users the new fields for address, and you'll see their relations to to-dos here. Let's start our server up. So the main change I'm going to make here is on our auth.ts file under the authorize. Now that we can establish that authorization here, we want to leverage this specific function to store the user information in the database. So to do that, I want to put back the Prisma, which I'll need to make those database changes. Scroll down to my authorize section, and this is where we're going to make the majority of our changes. So first thing I'm going to do is check if the user already exists. If the new user doesn't exist, I'm going to go through the process of creating a new user and then associating an account to that user. So credentials, Ethereum, and we're passing in the address. And you notice for each of these, whether or not it's a user or not a user that's not created, we're going to create a new one and establish a new user or a new entry insert with the wallet address. From there, I'm not going to return the address this time, but I'm going to return the user ID. So you'll see that instead of the address, I'm returning the user ID, and let's go to our app to see what that looks like. So here I'm going to click sign in, and you'll see that my user ID is shown instead of my wallet address, and we're able to see this secret message. Now that this session has been established, I have the user ID. The next thing I want to do is kind of built out the functionality for my to-dos. So you'll see here I have a task, the user ID, whether or not it's completed, and the association to a user. So in order to do this, I need to expose an API through tRPC in order to do those mutations of adding, removing, updating for that matter. And to do that, I'm going to go into server API routers, and you'll see there's an existing example one. I'm going to create a new one called to-do. And in my to-dos, I'm just going to paste in all this new code. If you're unfamiliar with Zod, this is a great way to be able to actually check the payload for specific typings and allows you to have those typings seen on the front end. We'll see that in a second. We're using tRPC as a router, so I'm going to return all that are associated to a user. So you'll notice here I'm passing in the context. I'm able to get the session and the user ID from that session. So I say return all the to-dos that are associated with the user. I want to add a new one. So this is a mutation as opposed to a query. And I'm going to say, hey, I'm expecting a task, whatever the string might be. And from there, I'm going to create a new to-do with the task input for that text, as well as the session user to do the association. I'm adding a remove. So give me the ID of that specific to-do. I'm going to remove it and make sure that it's associated to the user. So I'm not deleting any unnecessary to-dos that are associated to any other users. I'm also going to update things. So I'm going to make sure I get the ID, whether or not the task or the completion has been set. From there, I'm just going to check, hey, has it been set, update that task, and then do an update many where it's only applied to the ID as well as the session user to make sure that mutation has been updated in the database. What this all is essentially CRUD, if you think about it. So this is a list, this is a create, this is a delete, and this is an update, right? So all of this is essentially the basics of, if you're dealing with REST, it's just CRUD, but taking advantage of tRPC to be able to see those types on the front end. Next, I need to expose this on our root tRPC. So I'm just going to import the to-dos here and then add the to-dos router just underneath the example so that we're able to leverage now all those routes for the front end as well. One other change I'll make is to the example, because we'll notice that there's no database for the Prisma, for example, that table anymore. So I'm just going to remove that so that we have no errors specifically for those requests anymore. Next thing I'm going to do is create a new page called to-dos. In the to-do, I'm going to paste all this code. Again, all this code can be found in the actual Medium article, but I'll go line by line as to what's going on here. So I have a new to-dos page. I'm getting the session data. I have a use state to be able to persist that state of the to-dos on the client side. And the new to-do is for like an input that we'll see here to be able to add new to-dos and update that input field and then ultimately send that to the backend. We can see all our requests here. So you'll notice our API to-dos all query, which essentially is our to-dos tRPC referencing the all here. We're making sure that, hey, if there's no user that's been established or there's no session, don't make that request. But if there is a new success on whether or not, hey, there's something has been loaded, make sure that when it has been loaded that we're resetting our input field for adding a new to-do. We have our add here, so the same process, we're just doing a mutation. So we're adding something, taking advantage of the loading, whether or not, hey, we need to be able to disable specific fields while things are loading. On a success, refetch all the to-dos. And then we have a remove, same process. We're going to add a mutation, to-dos remove mutate, we have a loading state, and we're doing the remove.useMutate. And then on success, we're going to refetch all the to-dos again. And the same process for the update. So again, mutate, to-dos, update. Now, one thing you'll notice here is that I kind of combined all the loading states into one is request loading. Now, this is to make sure that I don't have to repeat myself multiple times in terms of typing this out. So anytime there's a new state change, I just want to make sure that any input fields or any buttons for forms are disabled so that they can't make a request in the meantime. Now, this is not always the most ideal, but it's just to make sure that, hey, if there's not multiple states kind of going through or multiple requests, and we're just going to wait for that initial request to finish before trying to submit another request. Here we have a function, which is an on form submit. So basically it's just, we have a form with an input. We'll see that in a second. I'm getting the specific field of what that new to-do might look like. And then I'm going to do an add mutate, which is going to add a new to-do to this user's table. We have toggle on and done, which is just a toggle for a mutation to set if a to-do is complete or incomplete. We have a click delete, Same process. The only thing is we're just passing in an ID to say, hey, I want to delete the specific to-do. And you'll notice here under use effects, I'm going to say, hey, if this is done loading, I'm going to set the use state or the local state to the to-dos data that's coming back from tRPC. So if it's still loading, don't do anything. But once it's done, load the data as an array to pass it to the UI. And then here we have our render. You'll see that briefly. I'll just show this in a second. But before we do, you'll notice that I have a list here that just shows all the to-dos and allows people to delete or toggle whether or not they're complete. And the form up top that we talked about, which is a new to-do. So if we enter a new to-do and press enter or click the submit button, it'll get submitted and processed as a tRPC request. So if we went here under our to-dos page, you'll see that we have a new homepage here with no to-dos. So I'm going to add a new to-do. So to-do 1, I'm going to click add it. You'll see that it's added. And we can also see that our requests are going through. So if I delete it, you'll see that that batch request for the tRPC has been done for that specific removal. Let's get well, this is the retrieval, but you'll see here under the network for the remove. So we'll go 1, 2, 3. These are our to-dos. I'll click this as a delete. You'll see that it has been updated. I'll remove this. You'll see that it's been removed. And the nice thing is if I go back to my home page and I sign out, and if I go back to the to-dos page, you'll see that I'm unauthorized, basically access denied for these to-dos because I need to be logged in and a session has to be established to be able to start storing these into the database. And the last thing I need to do is just add a button from our home page to reference our to-dos page. So I'm going to go to my code here under my index page. The thing I'm going to modify is my home page component. If I scroll down here under the paragraph, I'll paste this here. And what this is just a link to my to-dos page. So if I load the page itself again, you'll see the protected to-dos, access denied. If I click sign in, it'll prompt me to sign in to establish a session. I can go to my protected pages. You'll see that my to-dos are loaded again from the back end. And we can see here under our to-dos that the new to-dos are associated to a specific user. And we'll see our user here that's been established as well. And we're going to do one last thing, which is one thing I like is if you're familiar with Blockies. Blockies is basically just a library that allows you to create an image based off of a wallet address. And I kind of created my own. You can check it out at codingwithmanny/Blockies. And basically is if you pass in a wallet address, it will generate an image or an SVG for you that we're going to utilize for our main page. So if I stop the server and I'm going to go pm add codingwithmanny/Blockies, scroll up, and I'm going to add this new package here, render data URI. So what this will do is if you give it a wallet address, it'll return a base64 data URI so that you can just add to an image tag within your front end. And we scroll down under our auth session, we should see a new render here under our code for logged in as. And I'm just going to paste this here, which will say, hey, if the session user data exists, I'm going to load an image and then render their data URI with the seed user ID in this case. The scale is the size is 10 and the scale is 8, so that's the scale of the actual blocks itself. And you'll notice that I also forgot to import the next image. So if I scroll up, add this above here, save it, we should have no errors for our new image. So let's load our server again. Now if we refresh the page, we should see a base64 data URI for our image, which returns that specific graphic that's associated to our ID. It's a nice little add-on to have like sort of like a profile picture that's there in the meantime that's based off the user's ID. So let's recap. I'm going to sign out. I can disconnect my wallet, connect my wallet, sign in, reject, get the alert that I've been rejected, go to my protected to-dos page, nothing shows up. If I sign in now, signature, sign that, you'll see that the user data shows and that secret message that comes back from the back end. I'm going to go to my to-dos. I can add a new to-do. I can delete a to-do. I can undo or set it as done for to-do. And that's the entire process of integrating Sign-In with Ethereum with the T3 stack and adding a database connection with to-dos as well. Now, if you want to find out more, definitely check out the article I have called Combine Sign-In with Ethereum with Create T3 app, or the T3 stack in general. And also check out the repository, which is the Create T3 app. You can also see the fix for NextAuth 4.21.1 and the entire step to be able to just kind of set this up locally. And that is everything. If you like this, make sure to like, subscribe. If you want to see more tutorials about this, even let me know in the comments of things that you'd like to see me build more of. I would be happy to do this. One of the next steps I really want to do is integrate with another service provider, an authentication service provider that has native wallet interactions or these signatures with Sign-In With Ethereum, and be able to associate multiple types of accounts, like a Google account with a wallet address or a GitHub account with a wallet address. So look out for that. Again, like, subscribe, and I'll see you in the next one.